Type of polyvinyl chloride is rigid and strong. Its typical applications include pipes, fittings, siding, and window frames. It is designed to withstand high pressure and temperature. Type EB polyvinyl chloride is more flexible than Type A. It's often selected for electrical wiring, insulation, hoses, and medical devices. It offers good resistance to chemicals and weather. HDPE-EPEC consists of high-density polyethylene with an ethylene-propylene diene monomer core. This composition makes it very flexible and impact-resistant. Common applications include pipes for water and gas distribution, irrigation systems, and automotive parts. HDPE-EPEC is similar to HDPE-EPEC but utilizes a different EPDM formulation. This variation provides enhanced resistance to cracking and abrasion. It is frequently used in pipes for sewage, drainage, and industrial applications. Understanding the distinctions between these materials is crucial for selecting the appropriate type for specific engineering and construction needs. The rigidity and temperature resistance of type of polyvinyl chloride make it suitable for structural applications. The flexibility and chemical resistance of type EB polyvinyl chloride are advantageous in electrical and medical contexts. The impact resistance and flexibility of HDPE-EPEC are well suited for fluid transport systems. The enhanced durability of HDPE-EPEC renders it ideal for demanding industrial environments. Considering these properties ensures optimal performance and longevity in various applications. Type of polyvinyl chloride strength allows it to handle significant pressure without deformation. This makes it a reliable choice for water supply lines and structural components. Type EB polyvinyl chloride's flexibility simplifies installation in tight spaces and reduces the risk of damage from bending. Its resistance to chemicals protects it from degradation in harsh environments. HDPE-EPEC's high-density polyethylene provides excellent resistance to corrosion and chemical attack. Its EPDM core enhances its flexibility and impact resistance, preventing cracks and leaks. HDPE-EPEC's modified EPDM formulation further improves its resistance to abrasion and cracking, extending its lifespan in challenging applications. Selecting the right material depends on the specific requirements of the project, including pressure, temperature, chemical exposure, and installation constraints. Type of polyvinyl chloride is often the preferred choice for above-ground applications where strength and rigidity are paramount. Type EB polyvinyl chloride is commonly used for underground installations where flexibility and chemical resistance are essential. HDPE-EPEC is suitable for applications that require both flexibility and impact resistance, such as irrigation systems and automotive parts. HDPE-EPEC is ideal for industrial applications where abrasion and cracking are major concerns, such as sewage and drainage systems. In summary, the choice between these four types of reinforced non-conductive conduits depends on the specific application and environmental conditions to which the material will be exposed. Each type offers a unique combination of properties that make it suitable for different purposes. Careful consideration of these factors will ensure that the selected material provides optimal performance and longevity. Furthermore, understanding the manufacturing processes and material compositions can provide additional insights into their suitability for various applications. Type of polyvinyl chloride is typically manufactured through extrusion, a process that involves forcing molten plastic through a die to create a desired shape. The resulting material is rigid and strong, capable of withstanding high pressure and temperature. Type EB polyvinyl chloride is also manufactured through extrusion, but the process is modified to produce a more flexible material. Additives are often incorporated to enhance its chemical resistance and weatherability. HDPE-EPEC is produced through a co-extrusion process which involves simultaneously extruding two different materials to create a composite structure. The high-density polyethylene provides strength and chemical resistance, while the EPDM core provides flexibility and impact resistance. HDPE-EPEC is manufactured using a similar co-extrusion process, but the EPDM formulation is modified to improve its resistance to abrasion and cracking. This involves altering the ratio of ethylene, propylene, and diene monomers in the EPDM polymer. The properties of each material can also be influenced by the addition of various additives, such as stabilizers, lubricants, and pigments. Stabilizers are used to protect the material from degradation due to heat, light, and oxidation. Lubricants are added to improve the flow of the molten plastic during extrusion. Pigments are used to color the material and provide aesthetic appeal. In addition to their physical properties, these materials also differ in their electrical properties. Type of polyvinyl chloride is a good insulator, making it suitable for electrical applications. Type EB polyvinyl chloride is also a good insulator, but its flexibility makes it easier to install in tight spaces. HDPE-EPEC and HDPE-EPEC are also good insulators, but their primary applications are in fluid transport systems. When selecting a material for a specific application, it is important to consider not only its physical and electrical properties but also its cost and availability. Type of polyvinyl chloride is generally the least expensive of the four materials. Type EB polyvinyl chloride is slightly more expensive, while HDPE-EPEC and HDPE-EPEC are the most expensive. The availability of each material can also vary depending on the region and the supplier. In addition to these four types of reinforced non-conductive conduits, there are many other types of plastic materials that are used in engineering and construction. These include polyethylene, polypropylene, polycarbonate, and acrylonitrile-butadiene. Each of these materials has its own unique set of properties that make it suitable for different applications. Polyethylene is a flexible and lightweight material that is often used for packaging and films. Polypropylene is a strong and heat-resistant material that is often used for containers and fibers. Polycarbonate is a transparent and impact-resistant material that is often used for lenses and windows. Acrylonitrile-butadiene is a rigid and durable material that is often used for automotive parts and appliances. When selecting a plastic material for a specific application, it is important to consider all of these factors to ensure that the selected material provides optimal performance and longevity. Furthermore, it is crucial to consult with experienced engineers and material scientists to obtain expert advice on the selection and application of these materials. These professionals can provide valuable insights into the properties, advantages, and limitations of each material, helping to ensure that the selected material is the best choice for the specific application. They can also provide guidance on the proper installation and maintenance of these materials, ensuring that they perform optimally and last for many years. In addition to these technical considerations, it is also important to consider the environmental impact of these materials. Plastic materials are often derived from petroleum, a non-renewable resource. The production and disposal of plastic materials can also contribute to pollution and greenhouse gas emissions. Therefore, it is important to choose plastic materials that are recyclable or biodegradable whenever possible. It is also important to minimize the amount of plastic waste generated by using reusable containers and avoiding single-use plastic products. By making informed choices about the selection, use, and disposal of plastic materials, we can help to protect the environment and conserve resources for future generations. Finally, it is important to stay up to date on the latest advancements in plastic materials technology. New materials and manufacturing processes are constantly being developed, offering improved performance, durability, and sustainability. By staying informed about these advancements, engineers and designers can make better decisions about the selection and application of plastic materials, leading to more efficient, reliable, and environmentally friendly products and infrastructure.